For years now, the term Model 2 has floated around conversations, investor meetings, Twitter threads, and Tesla forums. It's not an official name. Tesla's never confirmed it, but the idea, crystal clear, a next generation Tesla costing roughly $25,000, $30,000, smaller than the Model 3, lighter, cheaper to build, and designed for mass adoption. Think of it as an EV built at scale, like a smartphone manufactured using next-gen casting and structural battery packs. With simplified engineering to slash cost and software doing much of the heavy lift, Tesla has said their next-gen platform could cut production costs by up to 50%. That's not marketing fluff, that's a manufacturing revolution. And where would such a vehicle be born? Inside Giga Texas, the beating heart of Tesla innovation. But here's where things take a sharp turn, because somewhere along the way this affordable EV concept collided with another Elon Musk company, a company whose satellites orbit the Earth every 90 minutes, a company called Starlink, WHY Starlink in a car. Starlink isn't just internet from space. It's low latency, high bandwidth global coverage. That means remote mountain roads, rural highways, deserts, developing regions, offshore routes, places where cellular networks fade to zero. Starlink dots and single quotes T dot. So ask yourself, what's the single biggest challenge for fully autonomous self? It's not only AI, it's reliable data everywhere. Always, a self-driving car is only as good as the stream of information coming in and going out. Imagine if navigation synced in real-time, traffic data updated every second, emergency coordination was instant, software updates downloaded anywhere on Earth, fleet learning never paused, voice and video calls worked no matter where you parked. And here's the kicker: vehicles become part of a global mesh network. Your car is no longer just a vehicle, it's a node in the world's largest moving internet system. So when insiders began whispering Tesla is testing Starlink hardware on next-gen vehicle prototypes, the internet exploded. Is it real? Is it practical? And why now? Let's unpack that. How would Starlink even fit in a car? You've seen Starlink dishes. They're not small, so how do you shrink that into a compact EV like Model 2? Engineers speculate 3 key breakthroughs. 1. Flat panel phased array antennas. These are low profile, vehicle mountable panels designed to communicate with satellites. Without needing to rotate, they can be embedded into the roof, hidden inside bodywork, or integrated under heat-resistant glass. Visually, you'd never know they were there. 2. Lower power satellite modes. Cars have limited energy budgets, so the system must optimize power draw, only firing when needed. 3. Hybrid connectivity. The car would automatically switch between 5G LTE when available, Starlink when coverage drops, seamless and visible, instant to the driver connection, just works. No buffering, no signal loss, no dead zones. Inside Giga Texas, what people are saying, Giga Texas isn't just a factory, it's a city under one roof. And inside, researchers, robotics engineers, supply chain teams, neural network developers, battery chemists, and automotive visionaries are working shoulder to shoulder. Recently, a growing number of anonymous voices, contractors, suppliers, logistics personnel have suggested experimental connectivity hardware is being tested alongside Tesla's next-generation vehicle architecture. Are they talking about Starlink? We don't know for sure, but here's what is confirmed. Starlink mobility hardware already exists and works on moving platforms. Starlink is now running on airplanes, RVS ships, construction equipment. SpaceX continues shrinking and optimizing. Antenna tech. Tesla interiors increasingly rely on connectivity for features. Put those dots together, and suddenly the idea doesn't sound so crazy. Why this matters for Model 2? The Model 2 isn't about luxury, it's about scale. If Tesla sells 2 million, 5 million, maybe even 10 million units per year, the world changes. As adoption accelerates, fuel demand shifts, charging infrastructure matures, cities replan, transportation now layer in Starlink. Every vehicle becomes a connected data stream, a software platform, a revenue channel, a learning node, a communication device. Tesla isn't just selling cars, they're building a planet-wide digital transportation grid. The manufacturing magic, how Model 2 may be built. The real secret to Model 2's price isn't Starlink, it's manufacturing. Tesla pioneered Giga casting, using giant casting machines to create huge structural parts of the car in single pieces. Fewer parts, less welding, less labor, faster assembly. Combine that with structural battery packs, simplified wiring harnesses, robot-heavy assembly lines, vertical supply chain integration, and suddenly at $25,000. Tesla looks not just possible but inevitable. Giga Texas is one of the facilities at the center of this, and if Starlink hardware is designed into the structure from day one, it's not an add-on. It's part of the DNA. The business model, follow the money. Here's where things get really interesting. Starlink isn't just a feature, it's a subscription service. Imagine low base vehicle price, optional Starlink, tier bundles with premium connectivity, data monetization for fleet analytics, business packages for fleet operators, emergency-ready packages for rural regions. Suddenly, Tesla's revenue shifts from one-time sales to lifetime recurring services, a dream for investors, a moat against competition, and a direct line between two Elon Musk ecosystems. The autonomy angle. Whether you believe in Tesla's full self-driving roadmap or not, one fact remains. Data is oxygen for AI. The more you have, the faster your system learns. Starlink, it turns every Model 2 into a full-time learning device, even deep in remote environments where data would normally drop. This means better map coverage, real-time fleet optimization, faster AI feedback loops, edge case discovery everywhere. That's not hype. That's engineering. Everyday life with Starlink in your car. Let's step away from factories and satellites for a moment. What does this actually mean for you? Picture this. You're on a long road trip through empty desert highway. Your kids are streaming movies in the back. You're on a video call for work. Maps update instantly. Your charging route optimizes that. You pull over at a remote trailhead and still have broadband. Or imagine, you're a rideshare driver. Your cabin becomes a mobile office. Passengers connect instantly. Payment systems stay online no matter what. Or you live in a rural area with weak infrastructure. Your car is your strongest internet signal. This isn't futuristic C-V. It's a logical step forward. Critics and reality checks. Of course, there are challenges and big ones. Critics point out cost of satellite hardware, power consumption concerns, weather impacts, regulatory approvals, physical space constraints, data privacy questions, cybersecurity requirements, repairability issues. These are valid, and we shouldn't assume Starlink-equipped vehicles are guaranteed. But technology always begins as expansive, rare and experimental. Then it shrinks, simplifies, scales, becomes normal. We saw it with GPS, touchscreens, Wi-Fi, Bluetooth, electric drivetrains themselves. What feels extreme today may feel boring in 10 years. Giga Texas, the heart of the story. So what exactly is unbelievable about Giga Texas? It's not secrecy, it's speed. Factories this large typically evolve slowly. Tesla iterates on the fly. Process improvements happen daily. Production layouts change weekly. Hardware updates roll out mid-stream. It's a living organism, and if testing of Starlink vehicle integration is happening anyway, Giga Texas is a logical guess. Does that mean it's confirmed? No, but it means the stage is set. The human element behind every breakthrough are thousands of humans. Engineers sleeping under desks, assembly workers perfecting motions, designers refining curves by millimeter, software teams chasing elusive bugs, logistics operators coordinating millions of parts. Innovation isn't magic, it's obsession. And the thought of these teams building a global, connected, affordable EV platform is staggering. What 2026 might look like. Let's time travel. It's 2026. The Tesla Model 2 launches. Not as hype, but as reality. A compact, stylish EV, priced under $30,000, range suited for daily life, charging everywhere, safety, top tier, and for those who want it. A Starlink package that keeps them online anywhere on Earth. Tesla doesn't just sell a car, they sell a lifestyle, a network, a platform, a membership in the most connected transportation grid humanity has ever built. And the industry shifts again. Final thoughts. The truth is, we don't know exactly what Tesla will reveal in 2026, but we do know this. Tesla doesn't think in model years, they think in systems. Starlink doesn't think in hotspots, it thinks in planetary coverage. And when those two worlds overlap, we may witness something far bigger than just another car. We may be watching the quiet birth of a planet-scale mobility network, one where your vehicle isn't simply a machine, but a living, learning, always connected extension of the digital world. And if that future truly begins inside Giga Texas, then yes, it's fair to say that really is unbelievable.